Okay, so today we're going to do a really quick lesson. It's a review of synthetic division, which is something that you guys probably learned in Algebra 2. So the first thing that we warmed up with was this question, 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. So the first thing we did is we put x minus 2 on the outside, and then we put the whole function we're going to divide by on the inside. The first question that we asked was, hey, what multiplies to 6x cubed? So x times what is 6x cubed? And what we came up with is that 6x squared times x is 6x cubed. So what we did is we multiplied 6x squared times x to get 6x cubed. And then we multiplied 6x squared times negative 2 to get negative 12x squared. After that, we subtracted. 6x cubed minus 6x cubed is 0, 0x cubed technically. And then negative 19x squared minus negative 12x squared, that's a double negative there, actually cancels to negative 7x squared. From there, I brought the 16x down, and we continue the algorithm. So the next question is, okay, x times what is negative 7x squared? Well, negative 7x times x is negative 7x squared. After that, I multiplied negative 7 times negative 2, which is positive 14x, and then I subtracted again. So negative 7x squared minus negative 7x squared is just 0. 16x minus 14x is going to be 2x. And then I brought the negative 4 down. From there, the last question was 2x times what? Basically, x times what is 2x? The answer is x times 2. So 2 times x is 2x. 2 times negative 2 is negative 4. We subtract these, we actually get remainder 0. And so what I know is that if I divide x minus 2 into this whole function, I get 6x squared minus 7x plus 2. So the factored form is what I wrote here. And factored form is just basically saying, hey, I could take a factor of x minus 2 out, and this would be it in fully factored form. All right, let's keep going. All right, so we just did some practice problems with these. We talked about the division algorithm. Basically, if you get a remainder, you can rewrite it a certain way, but we'll come back to that. All right, so we did this one, x plus 3x plus 5 divided by x plus 1. So what we did first, we put x plus 1 on the outside, and we put our function on the inside, x squared plus 3x plus 5. Using just basically the same principles as long division, we got x plus 2, but then we got a remainder. We got a remainder of 3. So what this remainder of 3 means is this, that when I divide x plus 1 into the function, I get x plus 2 plus technically 3, which is my remainder, divided by what I was dividing by, which is x plus 1. So this right here is what's left after I divide. This is where our division algorithm comes in. So if I have an answer, which is basically me saying x squared plus 3x plus 5 divided by x plus 1, it equals this whole thing when I divide it out. If I multiply both sides by x plus 1, the x plus 1 is going to cancel here, leaving x squared plus 3x plus 5. And using just a little bit of algebra, if I multiply this in, 3 over x plus 1 is just 3, and then x plus 2 is just x plus 2 times x plus 1. We can actually say that these two things are equivalent. So what I started off with, x squared plus 3x plus 5, is the same thing as x plus 2 times x plus 1, all plus 3, which we might end up using later, depending on how far we get. So that's just something we might use, we might not. But for now, we're just going to keep it as the division algorithm, which we might use later. All right, so some other things we talked about. We talked about synthetic division. So synthetic division is just the faster way to do long division. So synthetic division basically takes all of the coefficients and it puts them in basically a backwards division sign. So instead of the division sign being up front, it kind of now looks like I don't know, an XY axis is all I can think of. All you do is you put every coefficient in order from highest to lowest, like this. So in the case of x to the fourth minus 10x minus 2x plus 4, You're going to put 1 for x to the 4th. You're going to put 0 for x cubed. So technically what we did is we skipped a space. If we have x to the 4th, the space that we're missing is the cubed. So we're going to actually say plus 0x, plus, I don't know if I can go back. Sorry, plus 0x cubed. So we want to make sure every single space is filled in, minus 10x squared, minus 2x plus 4. So we want to make sure we're accounting for every single placeholder, including the cubic. Then we have negative 10, we have negative 2, and we have 4. So basically what happens here is you're going to take the 0 that you're dividing by. So we're dividing by x plus 3. That is equivalent to the 0 of negative 3 is equal to x. So what you're going to do is you're going to set this equal to 0 and solve. When I plug negative 3 in, here's what you're going to do. You're going to take the 1, bring it down, multiply negative 3 times 1 to give you negative 3, add 0 plus negative 3 to get negative 3, and then do the algorithm again. Negative 3 times negative 3 is positive 9. Negative 10 plus 9 is negative 1. Algorithm again. Negative 3 times negative 1 is positive 3. Add them and you get positive 1. Negative 3 times 1 is negative 3. Add them and you get positive 1. So the answer here is going to be x cubed. So notice how we power reduced. We're not starting at the 4th anymore. We're starting at the 3rd. X cubed minus 3x squared minus x plus 1 all over my remainder, which is 1 over x plus 3. So this right here is how we use synthetic. So we practiced this a bunch in class. We did a couple more examples here. So here's another example. Same process. You're going to solve for what you're dividing by, which is that negative 2. So if I solve it, I get negative 2 is equal to x. And then you're going to use synthetic. So basically what's cool about synthetic division is that when you're all said and done here, you can actually get factored form. So in essence, this is a great way to factor, and in the end, we're going to use it to graph. So if we end up taking the synthetic division, we actually get a remainder of 0, which is awesome. Technically, it'd be plus 0 over x plus 2, which cancels. So this right here goes in perfectly, which means x plus 2 has to be a factor. So I know that 5x cubed plus 8x squared minus x plus 6 is the same thing as x plus 2 times 5x squared minus 2x plus 3. So this is the factored form. So basically, if I get a remainder of 0, I know that this thing is going to factor perfectly. All right, so one more thing we talked about the remainder theorem. The remainder theorem is really interesting. It basically says that if a polynomial f of x is divided by x minus k, then the remainder has to be r is equal to f of k. So basically what we did in class is this. We went ahead and did long division, dividing by x plus 2, which means x is equal to negative 2, using synthetic, and we got a remainder of negative 9. What's super cool is that if you plug negative 2 into the function, you get the remainder, which is negative 9. And that's pretty much all we did today. We talked about the remainder theorem, we talked about synthetic division, we talked about long division, and we talked about the division algorithm. So those are all the things we covered, and we'll be probably picking up more of this tomorrow.